be solving problem set 3 of CS50's Introduction to Computer Science. I had done this course like way before, like in 2018, but probably there are like new problems now, and so I might not know the like actual algorithms required, but let's see, we'll figure it out. I'm planning to do it in like around 1 hour, so we are at 6:31 p.m. right now. It should be done by 7:30. So the first one is sort. Let's see. Recall from the lecture that we saw a few algorithms for sorting a sequence of numbers: selection sort, bubble sort, and merge sort. Selection sort iterates through the unsorted portions of a list, selecting the smallest element each time and moving it to its correct location. Okay. Bubble sort compares pairs of adjacent values one at a time and swaps them if they are in incorrect order. This continues until the list is sorted. Merge sort recursively divides the list into two repeatedly and then merges the smaller list back into a larger one in the correct order. In this problem, we'll analyze 3 compiled sorting programs to determine which algorithms they use in a file called answers.txt in a folder called sort. Record your answers along with an explanation for each program by filling in the blanks marked to do. Okay. We will need some distribution code that is written by CS50 staff, provided you are 3 already compiled C programs, as well as several text files for input and another file answers.txt in which you'll write your answers. Each of sort 1, 2 and 3 implements a different sorting algorithm: selection, bubble, merge, though not necessarily in that order. Your task is to determine which sorting algorithm is used by each file. Start by downloading these files. Okay, so I am inside the online editor. Let me choose my theme to be not light for sure. Yes, this is fine. What is this? Okay, let this. We can close this for now. Yeah. Oh wait, what happened? I got locked out. Okay. Click on the toggles below to read some advice. Okay, we can test and we can submit. Should I? Okay. Let's download the. We also have like tutorial as well, but let's see. Download the file. Unzip it. Remove the actual zip. Move to the sort folder. Visit. It's here. Okay. Sort 1 uses, sort 2 uses, sort 3 uses. Okay. We have random, reversed. Okay. Let's see. Reversed. The different types of text files may help you determine which sort is which. Consider how each algorithm performs with an already sorted list. How about a reversed list or shuffled list? It may help to walk through a smaller list of each type and walk through each sorting process. To run sort on this text files, terminal run program name. Make sure you have. Okay. You may find it helpful to time your sorts. To do so, run time sort and text file. For example, you could run real time to see. Okay, let's try running one. Should I increase the size a bit? Okay. let's say sort 1, and we'll try with random. Okay, it did print the sorted output, but I want to time it. 0.063, so we'll just add it here. We did random 5000, right? From what I know, merge sort is probably the fastest between the three, so we'll just figure out merge sort first. Let's do random 10,000. Oh, okay. For the 5000 it was 0.061. For the 10,000 it was 0. Okay. Then we'll do random 50,000. Yeah. It took a whooping 5 seconds. This is for random 50,000. Let's do. Okay, this will be boring a bit, but let's see. Now time for reversed 5, 10 and 50. Okay. This is taking a lot of time. Okay, for the sorted ones. Sorted 5000, okay. Now time for sort 2. What we can do to save some time is just directly run it like on the largest values, and then we can compare. So what I will do is, it's an already sorted value, right? Okay. Then sort 2 on random 50,000, let's say. It was way quicker. Let's do a reverse 50,000. Again quicker. Let's try sort 3. Okay, sort 3 on the sorted one. Sort 3 on random one. Similar. And we can do sort 3 on a reversed one. Interesting observation. If you see, sort 3 takes the same amount of time irrespective of the okay, but this is also same. Okay, if you see this one, the sorted one took like very less time in all the 3 cases. Reversed one took a lot of time. Oh man, I will need to add this in order. Let's just, this was sorted, this was random, and the last one was reversed. Okay, so some observations. If you see, this is almost same for all 3, this is also same for all 3, but for this one the random one took 5 seconds. Okay, reversed one took again 4 seconds, but the one which was already sorted took like very less time. So what I'm thinking is, this might be bubble sort, because bubble sort, like in each loop it makes like comparisons with adjacent numbers, but once there are no comparisons to make, like if it goes through a loop where there are no comparisons to make, that means that like we didn't swap anything, right? And that means that the list is already sorted. That's why like it short circuits the algorithm and then it stops there itself. So probably this is because sorted list took very less time, and bubble sort stops when there's no swaps needed in a loop. Okay, so it just like probably went through all the list just once. Like purely time wise, this one was the quickest in all 3 cases. So this can be merge sort, and that leaves us with selection sort in the end. Okay, should we, okay, this, are we sure merge sort will take the same amount of time, whether yeah how do we want the answers to be? used by each file, right? Okay, let's do it. Like I'll write bubble sort here. Selection and merge. Merge and selection. Okay. And for selection, how do you know? Because this one was the quickest. How do you know? Because, and here can be the only one left. I'll delete, copy this. Let's test. I don't know if I'm logged into the GitHub account already. Nice, we can submit. And I'll keep this in the file. Oh. Okay, let's see. Yeah, it passed. Okay, now to the next question. Let's do plurality. Okay. Elections come in all shapes and sizes. In the UK, the Prime Minister is officially appointed by a monarch who generally chooses the leader of the political party that wins them. Who generally chooses the leader, okay. Most seats in the House of Commons. United States uses a multi-step electoral college process where citizens vote on each state should allocate electors who then elect a president. This is the one that happens in India, like similar, I guess. Perhaps the simplest way to hold an election, though, is via a method commonly known as plurality vote, also known as first past the post or winner take all. In plurality vote, each voter gets to vote for one candidate. At the end of the election, whichever candidate has highest number of votes is declared the winner of the election. For this problem, you will implement a program that runs a plurality election as per below. Okay, so we make the program, we are running it. Alice Bob. Okay. Okay, like final example. Video is still running. Alice. Oh, one more. Okay. For this, we'll extend the distribution code provided by the staff. Let's do this. I'll download the code, exit out. Unzip it, remove the original zip file. Yes, go to the folder. Where is it in the side view? Okay, let's see. um, Executing code. Okay, understanding the code. uh, Whenever you'll extend the functionality of existing code, it's best to be sure to first understand it in its present state. Look at the look first at the top of the file. The line is some syntax. Max is a constant. Okay, I know that. Candidates and election can have. Plurality uses this constant to define a global array, which is an array that any function can access. Okay. In this case, is candidate in is a structure. Is structure has two fields: a string called name and int votes. Okay. Now take a look at the main function itself. See if you can find number of candidates in the election. What about where it copies command line arguments into an array? Okay, yeah, makes sense. Okay, for I is less than arg c is the total number of arguments, and arg v is the array containing each argument that we passed in the command line. Here we're doing -1 because the first element itself is the name of the program. So that's how we'll find. So you run the program by doing this, right? Plurality, then name of the candidates. So here the arg c is 4 because we have 4 arguments, and the number of candidates will be like 3. That's why we're doing -1. And similarly here we are initializing each candidate. Okay. Okay, number of votes we get int is like a probably CS50 is internal function. Program let every voter type in a vote calling the vote function for each candidate voted for. Finally, main makes a call to print winner to print out the winners. We'll leave it up to you to identify the code that implements this functionality. If you look further down the line file, though, you'll notice that vote and print winner functions have been left blank. Okay, this part is up to you to complete. You should not modify anything else in plurality.c file other than implementations of the vote and print winner functions and the inclusion of addition header files if you like. Click on toggles to in the ballot, printing the winner of the election if there is only one, if there are multiple winners. Okay, should I look at the hints directly or should I try to implement first? I think we can look at the hints. Single argument. Okay, yeah, if increment okay, print winner function should print the name who is the most votes and prints a new line. You might think a sorting algorithm would best solve this problem. Imagine sorting candidates by their vote totals and printing the top candidate. Recall though sorting can be expensive when merge sort or runs in. Consider that you need only 2 pieces of information to solve this problem: the maximum number of votes, the candidates with that number of votes. Only 2 such a side pseudocode to remind yourselves. Okay, yeah, makes sense. Let's try it. Okay, So name will be a string. Ah, okay. So, and we have a candidates array. Do we have one? Yes. Array, like it's a global array. So what we can do is we'll loop through the candidates array. Yes, and then find out if anyone matches. We have a pseudocode here, right? Iterate and matches if he has increment. So what we can do is for I don't know C very well right now, but let's see. I will start from 0. I will less than is less than candidate count, and I plus plus. Then we'll if candidates of I, this will give us a structure, this structure, and then I can just use dot notation, dot name matches the name that is given us in the I'm not sure if this will work because I don't know if C supports direct checking. We might need to use some string function, helper string function, but let's see. And I think the notation is like this, the style notation. If this matches, we just do this. We just increment the count. Plus plus should work. This is C, right? Let's see. And then we can just return, like we found a count, we found a candidate, and return true actually. Now how do I test the vote function? Let me make the program. It will be int I. It's not count, it's votes. Okay, my bad. Okay. Oh, zonal test. Number of voters, let's say 4. First vote goes to zonal. Invalid vote. So probably this is not working. Let's do one thing. What's the printf, right? Inside vote function, we'll do /n in the end. Printf, we want to print the name, candidate's name, but this won't work directly, right? I'll need to do percent s for string probably. And then the name of the variable I want to substitute for %s, and then similarly I will do %s, but this time I'll print the name. Okay, let's see. Oh, we need semicolon at the end of which. Okay, we were inside the vote function. It was Sonal but it didn't work. So what we'll need to do is probably string compare. Okay. Let's if strings are equal, we return 0, right? Okay. So what we can do is string compare, that's the function. First will be this, second argument will be this, and we just need to check whether this equals to 0 or not. Okay. Yeah, that worked. I can comment this out. This is done. Now we just need to find the winner. Why does it take void? Oh, because we are using the global variable. Now to find the winner, what first we'll find who has the maximum number of votes. So again we'll loop through all the candidates, and like max votes will be 0 initially. Okay, then if candidates dot votes, what am I doing? Okay, is greater than, yeah, greater than max votes right now. We'll just increment max votes to the whatever the vote that is. Okay, I can write too much used to Python. Increase my size. Okay. And now we just print all candidates with max votes. So it can be similar loop, but we'll just equal to max votes. We need to print, and how do we print? We just print in a new line. Okay, so printf percentage s, and then just the name of the candidate. And again there will be semicolon here, semicolon here. Let's see once. Four voters, all of them voted. Oh, this was commented out, right? Oh, I need to make it again. 4 voters. Let's say all of them vote for Sonal. The answer is Sonal. Again, 4 voters, 2 vote for Sonal, 2 vote for Test. Sonal and Test both win. Again, 4 voters, 1 Test, 1 voted for Ayush, invalid vote. Sonal, Test, Test, and Test. I think yeah, this is fine. We can try submitting. Let's see the style first. Oh, okay. Good. Yes. Now, do we check or do we just submit? Let's check. So once we're done with this, we'll only have Runoff and Tideman remaining. If you're feeling very comfortable, you're feeling more or less comfortable. Yeah, I'm feeling very comfortable. I'll do this if I do this first, like in the given time. Okay, all of them were passed. Let's submit. Yes, I'll in the meantime, charging is low. Okay, let's see the results. Yes, cool. Can close this out, get out of the directory, close this out. Okay, now what is Tideman? You already know about plurality elections, which follow very simple algorithm for determining the winner of an election. Every voter gets one vote and the candidate with most votes win. But the plurality vote does have some disadvantages. What happens, for instance, in an election with 3 candidates and the ballots are cast, below are cast. Okay, Alice, Bob, Charlie. Okay, a plurality vote here declare a tie between Alice and Bob. Yes, because they have same number of votes. But is that the right outcome? It's another kind of voting known as ranked choice voting system. In a ranked choice system, voters can vote for more than one candidate. Instead of just voting for their top choice, they can rank the candidates in order of preference. Thus, the resulting ballots might therefore look like below: Alice, Bob, Charlie, Alice, Charlie. Okay. Here, each voter is, in addition to specifying their first preference candidate, has also indicated their second and third choices. And now, what was previously a tied election could now have a winner. The race was originally tied between Alice and Bob, but the voter who chose Charlie preferred Alice over Bob. Yes. So, Alice could here be declared the winner. Ranked choice voting can also solve yet another potential drawback of plurality voting. Take a look at the following ballots. Okay, I don't have time. Who should win this election? In a plurality vote where each voter chooses their first preference, Charlie wins the election with 4 votes compared to only 3 for Bob and 2 for Alice. Alice, however, might reasonably make an argument that she should be the winner instead of Charlie. After all, of the 9 voters, a majority, 5 of them, preferred Alice over Charlie. So most people would be happier if Alice was the winner instead of Charlie. Alice is in this election the so-called Condorcet winner. The person who would have won head-to-head matchup against another candidate. If the election had just been between Alice and Bob or just Alice and Charlie, Alice would have won. The Tideman voting method, also known as ranked pairs, is a ranked choice voting method that is guaranteed to produce a winner of the election if one exists. In a file called in a folder, create a program to simulate the election. Let's see the demo. Okay. Okay. Let's run it again. Hmm. We'll download the distribution code. Okay, background. Generally speaking, the Tideman method works by constructing a graph of candidates where an arrow, that is an edge, from candidate A to B indicates that candidate A wins against candidate B in a head-to-head matchup. The graph of the above election then would look like below. Okay, and here Alice wins because, yeah. The arrow from Alice to Bob means that more voters prefer Alice over Bob. Likewise, the other arrow means that more voters prefer Alice to Charlie and more voters prefer Charlie to Bob. Looking at this graph, the Tideman method says that the winner could be the source of the graph. Yes. In this case, source is Alice. Alice is the only one who has no arrow pointing at her, which means nobody is preferred head to head over Alice. Alice is thus declared the winner of the election. It's possible, however, that when the arrow are drawn, there is no winner. Consider the following ballots. Okay, between to handle this, a treatment must be careful to avoid cycles in the candidate graph. How does locks in the strongest edges first, since those are arguably the most significant. In particular, that algorithm specifies that matchup edges should be locked in to the graph one at a time based on the strength of the victory. Okay, the more people who prefer a candidate over their opponent, the stronger the victory. So as long as the edge can be locked into the graph without creating a cycle, the edge is added, otherwise the edge is ignored. Well, biggest margin of victory for a pair is Alice beating Bob, since 7 voters prefer Alice over Bob. No other head to head matchup has a winner preferred by more than 7 voters. So the Alice Bob arrow is locked into the graph first. The next biggest margin is Charlie's 6-3 victory over Alice is locked next. Next is Bob's 5-4 victory over Charlie. But notice, if we were to add an arrow from Bob to Charlie now, we would create a cycle. Since the graph can't allow cycles, we should skip this edge and not add it to the graph at all. If there were more arrows to consider, we would look at those next. But this was the last arrow, so the graph is complete. The step-by-step process is shown below. Okay. Okay. Based on the resulting graph, Charlie is the source. So put more formally, the Tideman voting method consists of 3 parts. Tally. Once all the voters have indicated their preferences, determine for each pair of candidates who the preferred candidate is and by what margin they are preferred. Okay. Sort the pairs of candidates in decreasing order of strength of victory, where strength of victory is defined to be number of votes who prefer the candidate. Start with the strongest pair, go through the pairs of candidates in order, and lock in each pair to the candidate graph, so long as locking in that pair does not create a cycle. Once the graph is complete, the source of the graph, the one with no edges pointing towards it is the winner. Okay. Oh man, this one is the hard one, right? If I'm very comfortable, I could have done runoff first. Um, yeah, yeah, this one is the harder one. Let's do one thing, let's look at runoff. Oh, we'll need to read it again. Okay, you already know about plurality elections which follow simple algorithm. Yeah, just okay. Okay, same. Um, One such ranked choice voting system is instant runoff system. In an instant runoff system election, voters can rank many candidates as they wish. If the candidate has majority of the first preference votes, the candidate is declared winner. If no candidate has more than 50% of the vote, then an instant runoff occurs. The candidate who received the favor number of votes is eliminated from the election, and anyone who originally chose that candidate as their first preference now has their first second preference considered. Why do it this way? Effectively stimulates what would have happened if the least popular candidate would not be in the election to begin with. Okay, fewest is eliminated, and okay, okay. The process repeats. If no candidate has majority, the last is eliminated, and anyone who voted for them will instead vote for the next preference. Once a candidate has a majority, the candidate is declared a winner. Sounds a bit complicated than plurality, doesn't it? But it arguably has benefits of an election system where the winner of the election more accurately represents the preference of the voters. In a file called OK, create a program to simulate. Let's look at the demo again. Okay, distribution code, we'll download it again. Hmm. Okay, I'm not reading it out loud, but yeah, I got it. Now you can better understand preferences, two-dimensional array. The array preferences I will represent all of the preferences of voter number I. The integer preferences ij will store the index of the candidate from the candidates array without a jth preference of voter I. Okay, makes sense. Notice that determining the number of candidates and the number of votes, the main loop begins giving each voter a chance to vote. As the vote enters a preferences, the vote function is called to keep track of all the preferences. If at any point the ballot is deemed to be invalid, the program exits. Once all the votes are in, another loop begins. This one is going to keep looping through the runoff process for checking of a winner and eliminating the last place candidate until there is a winner. The first call here is a function to tabulate, which should look at all the voters' preferences, compute current vote totals by looking at each voter's top choice candidate who hasn't been eliminated yet. Next, print winner function should print out winner if there is one. If there is, the program is over. Otherwise, program needs to determine the fewest number of votes anyone still in the election received. Okay. If it turns out that everyone in the election is tied with the same number of votes as determined by the is_tie function, the election is declared a tie, otherwise last place candidate is eliminated from the election. If you look further down the file, you will see the rest of the functions. Okay. Takes three arguments: voter, rank, and name. If name is a match for the name of a valid candidate, then you should update the global preference array to indicate that a voter has a candidate as their rank. Okay, yes. 0 is first preference, 1 is second preference. You may assume that no two candidates will have same name. Okay. If the preference is successfully recorded, function should return true if false. Tabulate function should update number of votes each candidate has at this stage in the runoff. Recall that at each stage in the runoff, every voter effectively count one ballot. Recall that a voter I, the top choice candidate, is represented by once you cast a vote for a voter's first non-eliminated candidate, you will want to stop there and not continue down their ballot. You can break out of a loop early using break inside a conditional. Voter's first non-eliminated candidate. Okay. Print winner has more than half the vote. Their name should be printed. Return true. Find min. False, otherwise as you consider. Okay. Ah, here we are voting. Record vote until it's invalid, unless it's invalid. Okay. Record preference if vote is valid. Did this update with the submissions? Yeah, it did. Okay, let's do the vote function. So we do get, where is the vote function called again? Yeah. So I is the voter ID and J is the candidate ID. Okay. So if you see voter rank and name, that voter has that candidate as their rank preference. Hmm. 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 Got it. We are taking each candidate. We are taking number of voters. Array of candidates and preferences. We'll need to update the preferences in the vote function. So we'll just loop through all the candidates first. Less than, we do know the maximum number of candidates, which is candidates count. So I'll do this, I less than candidates count and I plus plus. Again we can use string compare, yeah, to check whether the name that we have given, name that the voter voted for, matches the name of the candidate. So that will be basically candidates of I write dot name. If this is equal, then only we'll do something, else we'll just return false. Now we want to update the preferences, right? So what we'll do is just do preferences of preference of this voter ID is voter is j plus 1. Okay, I can just do this then. Preferences of voter, and then this is the rank that right. Preferences I j is the jth preference for voter I, and this is an integer. Okay, and then so the preference for this, so basically what you're saying the ranked preference for this voter ID is this candidate index, right? And then we return true. Now we don't have a way to test this right now, but let's see. So assuming this is correct, we found a vote, we have populated the preferences array at this point. Now we'll keep holding runoffs. Okay, we'll calculate the votes given. Okay, we'll tabulate. What does tabulate do again? Update the number of votes each candidate has at this stage in the runoff. Okay, each voter effectively votes for their top preferred candidate who has not already been eliminated. Okay, okay, got it. Voter count stores the number of votes in the election, and that voters, each voter in an election, we want to count one ballot. Okay, yes. Recall that for a voter I, their top choice candidate is represented by preferences of I0, I1, eliminated from the okay, has a field called votes. Okay, once you cast a vote for a voter's first non-eliminated candidate, you'll want to stop there, not continuing down their ballot. You can break out of a loop. Okay, I'm a little bit confused. I think I'm like on sleep, but we'll do this. Now for tabulate, we want basically this, we want to update this vote structure for each candidate who has not been eliminated. So what we can do, we can just run over the preferences. Like we know the voter count is the length of this array, preferences array, and then within each array there will be like a separate array with each element consisting of max candidates, and that will be basically the number of candidates. Candidate count, let me just write it, like start writing, we'll figure it out. So for int I is 0, I is less than the max number of voters, which is voter count. And then I plus plus. So for which voter count we want preferences of I. Something to do with preferences of I. We can have another loop. 0j is less than candidates count. We don't have autocomplete. Okay, now basically first we need to check whether this particular candidate is eliminated or not. If the candidate is eliminated, we don't care about him and we can just skip that candidate, right? So what we can do is, if again candidates of if candidates of j dot eliminated, right? Is equal to true, we just want to break out of this particular loop. So we'll just move on to, do we want to break or do we want to continue? What we are doing is, for each voter we want to have their first non-eliminated candidate. Okay. So this is the for each voter, this is their preference. Let me write it down here. I, j is which is an index. Now I can directly go to the index, whatever that index is, and increment their number of votes. Only if they are not eliminated. If they are eliminated, I need to okay. So So this will be the preference. Index. So when j is 0, that is the first preference that candidate has, right? And now we can just check if that is eliminated. We don't care about that candidate. Do you want to break or continue? Oh, okay. Man, it's 7:42 already. Let's time bound to 8 p.m. instead. Whew. Should I take a break? No, this will be a one shot. Top preferred candidate has not already been eliminated. If eliminated is false, if this candidate is not eliminated, we will increment this candidate's number of votes. And then break out of it, right? So we are breaking out of this whole loop on itself, and then we are consider the other voter, second voter. So for the first voter, let's say their first preference is Sonal. We'll check if Sonal is not eliminated. No, it's not. Then we'll increment the vote of Sonal because that was the first preference, because we are in the loop for the first time, and then we'll break. But let's say if Sonal was eliminated, then we won't go inside. We'll find a second preference of this particular voter, and then second preference again we'll check whether it's eliminated. If it's eliminated, then we'll find the third preference. Let's say third preference is not eliminated, then we'll increment the vote of that candidate, and then we'll go to the next voter. Yeah, makes sense. Now the only question is, are we resetting the number of votes to 0 somewhere in the code above? We tabulate, we find min. Yes, we are resetting it to 0 in the main loop, so we don't need to take care of it here. Yep. Now we need to find a winner if there is one. So again, I'm looking at the hints. I shouldn't, but okay. I think I know like roughly what to do here. If any candidate has more than half of the vote, the name should be printed and should return true. If nobody has won the election yet, the function will return false. Voter count stores the number of votes in the election. Given that, how would you express the number of votes needed to win the election? Okay, so this looks pretty straightforward. we know voter count, right? So then, so half will be more than half, right? So basically int like required votes to win will be voter count right divided by 2. Now since this is an integer and this is an integer, I think this will be an integer and this will be like rounded off to the nearest value, which is okay. Let's say there are odd number of voters and then 2.5 will be the answer, but it will be 2. But if anyone has like more than 2, that is 3, then we win. But let's say if there are 3, yes, more than 2. Okay, now we just loop through the candidates again. Okay, now what we'll do is if this particular candidate has more than half votes, so candidates of J if candidates of J dot votes if right is greater than like required votes to win, we just return we just print and return. Yeah, we just print percentage s slash n dot name and then we return true. Okay, we need to find the minimum votes to eliminate minimum vote total for any candidate who is still in the election. Has fewest number of votes. What information should we keep track? Oh wait, for the winner we want to find like if it's not eliminated, right? Yeah, so what I can do is, I don't know if they, okay, let's say candidates of J not eliminated is equal to false, right? And this, so this candidate is not eliminated and their number of votes are more than required. Will print winner run every loop? So yeah, I don't think this is required, but still I'll keep it for now and then we'll test again with removing this, because anyway if a candidate is eliminated we don't consider their vote, like we don't add to their vote, so anyway their vote will be 0 if someone is eliminated. We need to find the min, right? and we just try to return the minimum number of votes. Okay, so we'll again loop through all the candidates. If they are not eliminated, so first of all, min will be min. What will mean? Yeah, what's the max vote that a candidate can get? That will be max voters, right? So it will be basically min votes, int of min votes. This will be max voters initially, but since and again votes is less than min votes, we will update min votes. Okay, returning 0 for some reason in the end. No, we need to return min votes. Yep. If it's a tie, if the election is tied between all candidates, we just need to find whether all the candidates have same number of votes, all the remaining candidates. So again, it's not eliminated and their votes is equal to min. If it's not equal, they are eliminated. They're not eliminated. And their votes is not equal to min. We'll just say tide is equal to false, right? And then we'll return tide, and tide will we'll say bool of tide is true initially. We just need to eliminate a candidate with the min number of votes. Again, we'll loop through all the candidates. We'll see if they are not eliminated already, and their votes is equal to min. And if that's the case, we'll make it true. And we just return. Okay, let's try running. Yeah, this will be int. String.h is not there. Okay. Yeah, this will be int. This can be at the top. Okay. Sonal and test voters. Only 2 voters. So rank 1 is Sonal for the first voter and test for the next voter. Rank 2 is also Sonal for the first voter and test Sonal is a clear winner, both of them. Uh, let's make a try. Sonal, test, test, Sonal. It returned both of them. I don't know if that's expected, or do we return a tie? Yeah, we just print and return. Are you supposed to return tie? Printing the winner of the election if there is only one. So what are you supposed to see? You're supposed to return ties. How many printf statements are there? Okay, this is fine, this is fine. This is fine, this is fine. Okay, I just print. Okay. So is my print winner function wrong? What's required to win? Let's also do one thing. Let's also print the vote. I need to. So what I'll do is what? Why is this change not reflecting? Is this even, where are the candidates been printed from? Let's run again. Let's have a clear winner this time. Okay, now it printed Sonal 2. Now if I do let's do one thing. Number of voters will be into sonal test sonal. Oh, something is wrong. If it's a tie, ah, okay, if it's a tie everyone wins. Okay, I think that's expected then. But if one we break, okay, then I guess we can just keep this. Should I style? Let's run style 50. This was not needed. Okay, that was the only thing. I don't know. Oh, nice. I thought when there's a tie we don't need to print anything, but apparently that's not the case. Okay, we can submit. So just for a recap, I think the most tricky part was this tabulate function, for me at least. Maybe I'm not like totally awake. Apart from that, yeah, everything was like straightforward. So if anyone has doubt, like you can ask. I don't know. This is done. Now only Tideman is remaining, which we were like halfway through, but I'll probably make another video for it like sometime later. I'll solve it separately, but I should be done with all these three for now. So week 3 is officially done. Let me check the yep. Okay, I'll probably solve week 4 problems too separately. Thanks if anyone watched. Bye.